Okay, students, let's join. We are seeing the 8th class NCERT maths, right? That is the chapter called. See, we are uh, doing this series on the 8th class NCERT maths. Okay, and we started the chapter 1, that is called the rational numbers, and in that now we are seeing the exercise. Okay, so we did yesterday few problems on that, and remaining we will see now. Okay, we are doing the 8th class maths exercise 1.1. Okay, 8th class NCERT maths, that is chapter 1 about the rational numbers. Okay, we saw yesterday few problems. Okay, that is 1.1, exercise 1.1. Okay, so now we will see the remaining questions. So the question I will write here. We saw in the chapter rational numbers, we saw the closure property and the commutative and the associative property for the whole numbers, integers and the rational numbers. And after that we saw the role of the 0 and the role of the 1, or you can call it as an additive inverse and the multiplicative inverse. Okay, the additive inverse is nothing but just how to take the reverse the sign of the number. Okay, if we add together, no, we should have to get the 0. So in the case of the multiplicative inverse, we will just reverse the number. So after reversing the number and that original number, if you multiply, the product, we should have to get the 1. Okay, so this is about this chapter, the concept we learned, and now we are solving the exercise 1.1. In that, in the previous class we saw the few questions, and now this is a continue part of that. Okay, now I will write the question. See here, in the answer it is question number 5. Name the property under multiplication used. Under multiplication used in each of the following. The first question is, see here, minus 4 5 divided by 5 into the 1 is equal to 1 into minus 4 divided by the 5. And the second question is, minus 13 by 17 into minus 2 by 7. This is equal to minus 2 by 7 into minus 13 by 17. And the third question is minus 19 by 29 into 29 by minus 19 is equal to 1. Okay, in the exercise 1.1 in the NCERT, they name the property under the multiplication used in each following. Okay, and we have to tell which property they used here. Okay, one by one we will see. Here multiply any number with the 1, we will get an original number. Okay, so that time this 1 we call it is a multiplicative identity, right? This one we studied, right? The role of the 0 and in the case of the role of the 1. Now if you multiply any number with the 1, we will get the again original number, right? The 1 we call it is a multiplicative identity. Okay, the which property used in this here? They used the multiplicative identity property. Then this is very simple. It is an A and B, and this is here B and this is A. Means A cross B is equal to B cross A. Which property? It is a commutative property, right? This is a commutative property they used. And here you have to see. Here this is a see. This is one rational number called as an A, and this is a 1 by A, right? Then this is an what? This is a multiplicative inverse, right? In the multiplicative inverse, what will happen? A into 1 by A will get a 1. So this is a multiplicative inverse. So here they use the multiplicative inverse property. Okay, just they reverse this fraction, and if you multiply both together, now we will get a 1. Then if you are getting, after multiplying the 1 we are getting, means here this quantity we call it a multiplicative inverse. So in the third they use the multiplicative inverse property. Okay. And the question 6 we will move on. What is the question 6? Exercise 1.1 in the 8th class NCERT Maths. The question number 6. This is very easy. Multiply 6 by 13 by the reciprocal of the, see they told us, multiply 6 by 13 by the reciprocal of minus 7 upon 16. Then they told us to, for this number we should have to multiply reciprocal of this number, 6 by 13 into what is the reciprocal of this. Just have to reverse the fraction. It is a minus 16 upon 7. Okay. Then if you multiply, then it is a minus 96 divided by the 91. Okay. This is very, very simple. And the question number 7, they told which property allow to compute this problem. Again here we should have to tell which property they are applied. This is very, very easy. Here the 3 numbers are there, and for that either you have to multiply these first or you have to multiply first. Then this is an associative property, right? Associative property in case of the multiplication is A into B cross C. Either you have to multiply this bracket first or A cross B into C. Okay, this is an associative property in the 7th question. Take the screenshot and we will move to the 8th question. Okay, so what is the 8th question? I will write here. The 8th question is 8 by 9 is the multiplicative inverse of the minus 1 by 8y or y naught. Okay, the question is 8 by 9 is the multiplicative inverse of minus 1 upon 1 by 8 y or 1. We should have to tell the reason. Okay, is 8 by 9 is the multiplicative inverse of the minus 1 into 1 by 8. We will see. See here, for the multiplicative inverse, for the in general, I will take the right marker, wait. For the in general, For the multiplicative inverse, how we will do? For the any number a into 1 by a, and this is a multiplicative inverse of this number, and the product of these we should have to get the 1. Okay, now we will check. The 8 by 9 is they told it is a multiplicative inverse of this number into and minus 1 into 1 by 8. This is how we have to multiply like this. Minus 1 into 1 by 8 is nothing but 8 ones are 8, and this is plus 1, means it is minus 7 by 8. Okay, so it is minus 9 by 8, right? Have to add this plus 1, right? Okay, then sorry for it is 9 by 8. Okay, minus 9 by 8 means this is how you know minus 1 plus 1 by 8, or you can add minus 1 into, this is how you know, this is in here it is multiplication, means just you have to forget this minus sign. 8 ones are 8 plus 1 numerator and divided by the 8. It is a mixed fraction. Okay, this is a mixed fraction. It means in the mixed fraction, suppose 1 into 1 by 3. This is nothing but 1 plus 1 by 3. Or this is nothing but what? This 4 by 3. Or you can write 3 ones are plus 1. It is a 4 by 3, right? Like this. So this is minus 9 by 8. Then now we will see the product of these. We should have get the 1 here. Here minus 9 by 8. And this 9 and will get cancelled. We got the minus 1. But what we should have to get? The product, there is a multiplicative inverse and this is the origin. To multiply these, we should have to get the plus 1. But here we got the minus 1. So obviously, this is not a multiplicative inverse of minus 1 by 8. We have to write in the conclusion, 8 by 9 is not a multiplicative inverse of this number. Okay. So take the screenshot and I will erase. So we will move to the next questions. Okay. We will move to the next question. Take the screenshot. Okay. Now. Question 9, similarly with the question 8 only, this is 0.3 is the multiplicative inverse of 3 into 1 by 3. Why or why not? We should have to tell the reason. Okay. So, similarly, that question only. For the multiplicative inverse, for any rational number you can call. See here the solution. How we have to solve like these questions. We know multiplicative inverse, right? For any rational number a, right? So for the multiplicative inverse this is for any rational number. 1 by a is this is what it is? It is a multiplicative inverse, and if you multiply multiplicative inverse into the number, we should have to get the product as a 1 here. Now we will see. They told 0.3 is a multiplicative inverse of the 3 into 1 by 3. So 0.3 I can write 3 by 10, and that is around 3 into 1 by 3. I can write 3 3 is 9 plus 1 10 by 3. Now we have to multiply. This is the original number. It's called an A, and this is an inverse. This is a 1 by A, right? So they gave already in the 1 by A form. There is no need to again convert. Then A into 1 by A, you should have to get the product as a 1 here. Then what is the A? 3 by 10, and 1 by A is this one, 10 by 3. And if you get cancelled, we got the 1. Oh, so this is answer, yes. The 0.3 is the multiplicative inverse of the 3 into 1 by 3. Okay. And now we will solve the question number 10 and the question number 11. The question 10 and the 11 are the very, very important. Okay. Take down the screenshot. The question 10 and 11 are the very important questions, okay? Okay, now I will write the question 10 and 11. The question number 10. In that first one, the rational number that doesn't have any reciprocal. You should have to tell the answer. In that second one, the rational numbers that are equal to the reciprocal. Okay, and in that, the 10th question, the third one is the rational number that is equal to its negative. Okay, and the question 11 also I will write here only. It is in the fill in the blanks. The first one in that, take down the questions first one by one. The first one, 0 has what? Dash reciprocal. And in that, the second question is the numbers dash and the dash are their own reciprocals. Okay, and the third one, the reciprocal of minus 5 is. These are the very basic and the important questions. Okay, you won't think it is a very, very simple question. The chapter is very simple. First of all, but it builds the basic. Okay, 1 by x where x is not equal to 0. And the fifth one, the product of the two rational number is always what? We should have to write the answer. After this, again we will move to the how to represent the rational numbers on the number line. We will see the reciprocal of a positive rational number is. Take down the question solve and we'll solve the one by one, and after this we'll have the next concept called that one is how to represent the rational numbers on the number line. Okay, this is exercise 1.1 8th class NCERT chapter 1 maths chapter, that is rational numbers. So in that we are solving the 1.1 and the question number 10. What is the question number 10? Okay, the question 10 is in that first one, the rational number that doesn't have any reciprocal. Okay, we have to tell which rational number that doesn't have any reciprocal. Okay, you have any answer? See here, the rational number that doesn't have any reciprocal. For example, you can take the 2. 2 has the reciprocal is what? 1 by 2. And minus 3 is a minus 1 by 3. So 5 is a minus 1. So 5 is a 1 by 5 reciprocal. 10 is a 1 by 10 is a reciprocal. Then you have to tell the rational number that doesn't have any reciprocal. That is 0. No, answer is a 0. Means 0 is a rational number. Once again I will explain why 0 is a rational number. Okay. For what is the definition of the rational number? I will explain once again. What is the definition of the rational number? For the rational numbers, it is in the form of the P by Q. Okay, then what are the P and Q are here? P and Q are the integers. P and Q are here the integers. You know integer set, in that we are having the whole numbers and the negative numbers. And the one more important condition is what? Second one, Q is not equal to 0. Means the denominator can't be 0. The numerator can be the 0. Here, the numerator can be the 0. The only thing, denominator can't be the 0. This is about the rational number. Here, the 0 is a rational number. How? 0. This 0 I can write in the form of the P by Q. How? 0 by 1. Nothing is there in the denominator, means it's always a 1. Okay. So, the P numerator can be the 0. Only thing, Q can't be the 0. Here, Q is a 1. And the 0 and 1 are the what? 0 and 1 are the integers. The first condition what? P and Q are the integers. 0 and 1 are the integers, right? And the Q is not equal to 0. Means the denominator can't be 0. Here the denominator is 1. So the 0 is a rational number. Now the rational number that doesn't have any reciprocal. So 0 has doesn't have any reciprocal. Means 0 not having the reciprocal. How? The 0 is a rational number. If I want to write reciprocal of the 0, how I will write? 1 by 0. Here, 1 by 0 in the maths is what? It is a not defined term. Okay. In the mathematics, the denominator can't be the 0. It is a sin. Okay. Means I'm telling in the sarcastic way. 1 by 0 in the maths, the denominator can't be the 0. Because it is an undefined term. Okay, so if you write the reciprocal of this 1 by 0, it is an infinite or the not defined. That's why the 0 doesn't have any reciprocal. Okay, what is the reason behind that? You got the point? Now, the second one. First, I want to read this one and second one. The rational numbers that are equal to the reciprocals. We should have to write the which rational number that are equal to the reciprocal. Means it is 1 and the minus 1. 1 and the minus 1. How? See here. The 1 is in a number. If I want to write the reciprocal of this, I will write 1 by 1. 1 by 1 is what? Again it is in a 1. Similarly, minus 1. And what is the reciprocal of minus 1? Minus 1 by 1. Then minus 1 by 1 is what? It is again a minus 1. So these are the reciprocals and these are the original numbers. See here, the reciprocals and the original number are the same and this also same. That's why the rational numbers that are equal to the reciprocals are the 1 and the minus 1. The 1 and the minus 1 are the two rational numbers. The reciprocals also, for that it is in the same. Okay. Now we have to read the third question. The rational number that is equal to its negative. So I think it's a 0. 0 is neither positive and not negative, right? 0. Because the rational number that is equal to its negative. You can write it is a neither positive neither negative. It is 0. And 11th question we have to read. Question number 11. Exercise 1.1. The fill in the blanks. Okay. Again enough explanation how they came. The 0 has the first question only. This only they again gave in the fill in the blanks. Okay. The 0 has no reciprocal. Why? I explain here. Then the numbers are their own reciprocals. Again it is on 1 and the minus 1. Again this question only I think they gave in different way. Okay. The numbers 1 and the minus 1 are their own reciprocals. Okay. And the next one, the reciprocal of minus 5 is what? The reciprocal of the minus 5 is a minus 1 by 5. This is very, very simple. And the reciprocal of 1 by x. Here, the y they mentioned here, x is not equal to 0 means in the math, the denominator can't be 0. If it is 1 by 0, it is not defined. In math, the numerator can be the 0, but the only thing you should have to remember, the denominator can't be 0. Simply they won't write the condition here, because every time you observe in the question, whenever the denominator is containing x and y, the any variable, they will tell you except 0 you should have to take the other numbers. Why? If you take the 0, the solution becomes not defined. That is why they will mention in it is a mandate, because you should have to the, that's why they will mention here. Why x is not equal to 0? If you keep x equal to 0, then these terms becomes not defined. Okay, the reciprocal of 1 by x is what? It is an x only, no? See, this is a number, the reciprocal of 1 by x, right? So the how this one you will write? If it goes numerator, right? It is an x. You got the point? And the product of the two rational number is always a rational number. Okay, the product of the two rational numbers is always a rational number. You can take the 2 and 3 are the two rational numbers. Okay, all the integers are the rational numbers, and the 2 and 3 also rational numbers. If you multiply, the product means what? The multiplication. 2 into 3 is what? 6. 6 is again a rational number. And the last question, the reciprocal of the positive rational number is what? Okay, the reciprocal of the positive rational number is again a positive. Is very simple. How? See, here the 5 is a one positive number. What is the reciprocal of this? 1 by 5. Again this is a positive, right? If here it is a negative, I will get a minus 1 by 5. If it is a negative, to negative I will get, here they mention the reciprocal of the positive rational number. Then we will get a positive inverse. Okay? You got the point? So please take these notes. These are the very, very important. This builds your the basic concept. It will helps in the upper classes. Okay. I feel the question 10 and the question 11 are the very, very, very important, because so many students they don't know about the basic. Why we won't have the reciprocal 1, 0 and all. Okay. So take the screenshot and we'll move to the next concept. Okay. So take down the screenshot and we will move to the next concept. Okay. Okay, I will erase. So now we'll study the representation here. Representation of the rational numbers on the number line. Okay, so we are representing the rational numbers on the number line. First one, we know how to represent the natural numbers on the number line, right? See, this is a number line. Again, the natural numbers also, again rational numbers. So 0, 1, like this will represent, right? This minus 1. So we are representing natural numbers. Okay. Or you can see in one number line only I will tell you the natural numbers and the whole numbers, and the third one is in integers. Okay, these all we are representing on the number line, right? If you leave this part, the remaining is in a natural line. If you just minus ignore this negative, including the 0 we call it the whole numbers, and the negative plus whole numbers we call it the integers. This way we will represent on these natural numbers, whole numbers, integers on the number line. Now we will represent the rational numbers which is in the P by Q form. Okay, on the number line. How we will represent? See. This is very easy. Okay. So now take here. For example 1 by 8. I want to represent on this number line. This 1 by 8 it is in the form of P by Q or the fraction form. So what we have to do? See, the 1 by 8 it is lying between the 0 to 1. 0 I have to take here 1. Okay. The denominator is bigger and the numerator is small. Obviously 1 by 8 lies between 0 to 1, or if you don't want how it will come means just you have to divide like this. 1, 8. It doesn't goes right with the 8 because it's smaller number. I will keep the 0 and I will take the 0 here. In 8 1 the 8 is 2 left. Again I will give the 0, 16. Like this, right? 0.12. It lies between 0 to 1. Okay. This is equal to 0.12. 0.12 lies between This 0 to 1. Now what we have to do? Here the denominator has the 8. Means we have to do the 8 equal parts between the 0 to 1. Means 8 means 7 dots. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Here it is 1. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Now this is an so we did the 8 parts. How? 1 by 8. You have to take the 8 equal parts here. Then you have to represent 1 by 8, 2 by 8. This is 3 by 8, 4 by 8, and this is 5 by 8, 6 by 8, 7 by 8. This is equal to 8 by 8. 8 by 8 is what? 8 by 8 is 1 only, no? Okay. So the 1.8 where? This is here. If they ask you 1 by 2, 1 by 2 is here, right? 4 by 8 is what? 1 by 2. The remaining fractions, if they ask 6 by 8 is here. How you will represent? You have to think that this fraction as a rational number, the in between the which two natural number it is lying. So after that you have to see the denominator parts. If it is 8 means we have to divide the in between the two natural numbers, we have to divide the equal parts. Then we have to start from here the numerical denominator. We did the 8 equal parts, right? After that we will go to the numerator part. Then it is a 1 by 8. This is a 8 is what? Whole part. And 1 is in that. Okay. In that we are having the one part in the 8 part. Okay. In the entire 8 term we are having the first part. This is 1 by 8. Again we will represent the one more rational number. Okay. See. I will show you. Or you can take the minus 7 by 4. Now we will represent the negative rational numbers. You have to make this line. This is a real axis. Then you have to think, just ignore the minus now. The 7 by 4, the lies between which number? Which two natural numbers it is lying. So if you don't know, just have to divide like this. Okay. It is 4 ones are 4. It is 3 left. Then 3 can't go. Keep the 0. 28. Again 2. 4 5s are 20. So this is nothing but a minus 1.75. 1.75 means it lies between the, if it is here, take the 0, the left side of the real axis. You take the minus 1. So you have to take here from minus 1 we are considering. Okay. If you take the here 0 and if I will take the minus 1 and in between the minus 1 and minus 2 it lies. Okay. So it lies between the minus 1 and the minus 2. Take a bigger part. It should be the equal, right? Minus 1. The minus 1.75 lies between minus 1 and 2. Now you have to see this part. 4 equal part. Means we have to do the, in between these two, you have to do the 4 equal parts. 1, 2, 3, 4. Okay. Then and here it is a see from the, we have to start from the, this is in the negative side, right? Means it is a minus 4 by 4. Then only it is a minus 1. Okay. Then this is a minus 3 by 4 minus 2 by 4 minus 1 by 4. Okay. You got the point? Then it is minus 4 by 4 means it is minus 5 by 4, minus 6 by 4, minus 7 by 4. Okay. You got how we are representing? Then minus 7 by 4 is here. This is the way how to represent the rational numbers on the number line. Okay. What how to just how to check the rational number, the which two natural numbers are the in the integer it is line. And one more thing, here in the real axis, right? This is 0. Here we are having the negative integers, and this side we are having the positive integers. From 0 to the right side, the value of the number will increases. Okay, this is how to remember. And the 0 to the left side, the value of the number will decreases. And I will ask here one question. From here 0 to the left onwards, the value of the number will decreases. Then 0 is greater than the minus 1. You will agree with this? Okay. Then minus 2 is less than minus 1, because to the left side the number of the value is increasing. Here 0 is bigger. Means from here to this where value is decreasing. That's why minus 3 is lesser than the minus 2. Minus 2 is lesser than the minus 1. Okay, you got the point. But in the left side, 1 is less than the 2, 2 is less than the 3. Because from this right side, the value of the number of value will increases. Okay, this point you should have to remember. So how to represent means just how to think this rational number, the which two number it is lying, then see the denominator parts, according to that make the equal parts, then you have to represent with the that number. It's very easy. Okay. So I will rub now. Now we'll see the how many rational numbers are there in between the two rational numbers. Okay, these are the very important question. See here. Now we are seeing the rational numbers between the two rational numbers. So if I ask you, can you tell the natural number between 1 to 5? 1 to 5, what is the natural numbers? It is in 2. See, if I ask you, what is the natural number between 1 to 5 is what? 2, 3, 4, right? Then if I ask you, how many natural numbers are there between the 7 to 9? It is 8 only, because we are seeing the natural numbers. Okay? We are getting this point? Or else if I ask you, how many natural numbers are there? If I ask you, how many natural numbers are there in between 10 and 11? Is there any possible the natural number lies between 10 to 11? No, right? So here there is no natural number between the 10 to 11. Right? Obviously we are having the none as the answer. So if I ask the list the integer that lie between the minus 4 to 4. So how we will write? If I ask you list the integers minus 5 to the 4. Then it is minus 4, minus 3, minus 2, minus 1 and 0, 1, 2, 3, right? We are getting? Then how many integers are there? Then again if I ask the question, how many integers are there between the minus 1 to 1? You have the any answer for this? And similarly if I ask you, how many integers are there between minus 9 to the minus 10? You have any answer for these two questions? Okay, there is a here there is no integer, right? You got the point? Is there any possible the minus 1 minus 1 to minus 1 to 1, which integer is present? 0. In between minus 2 to the 1, the 0 is present. 0 is belongs to the again integers. Okay. Then if I tell you list the integers between minus 9 to the 10. Is that any possible? The in between the minus 9 and minus 10, is there any integer number lies? No. Here no. Because if you draw the axis, no, here minus 9. In it is minus 10, minus 11. In between the two, these are only the two integers. In between again, there are the any integers? No, right? Or not at all possible. Now we will see with the rational numbers. Now we saw with the natural numbers and the integers. Now we will see the how many rational numbers are there in between the two rational numbers. Okay. Now in the previous slide only we represented the rational numbers on the number line. Okay. Now we will see the in between the two rational numbers how many rational numbers are present. Okay. Here I will ask the one question. How many rational numbers are there? Rational numbers are there between the 3 by 10 to the 7 by 10. Okay, I told you already how to represent 3 by 10 and 7 by 10 on the number line. Okay, if you take this draw, then make the equal parts, lies between the 0 to 1. Okay, 0 to 1 it lies. So you have to make the denominator 10 equal parts. Okay. Okay, this is a 1 by 10, 2 by 10. See, it is a 0 by 10. 0 by 10 is equal to 0. And 3 by 10, 4 by 10, 5 by 10, and 6 by 10, 7 by 10, 8 by 10, 9 by 10, is 10 by 10 is equal to 1. So 3 by 10, here it will come. And the 7 by 10. Again here you can see it clearly how many rational numbers are there between 3 to, means you may thought there are these three rational numbers are there. Okay, but what if I write, see, you may think these three rational numbers are there in between the 3 by 10 to 7 by 10. So the 3 by 10 I can write like this. Okay, 3 by 10 I can write 30 by 100, and the 7 by 10 I can write 70 by 100. Then nothing but the same again. Okay, 3 by 10 is equal to 30 by 100. If you cancel these two zeros, then I get 3 by 10 only. Now if I ask you how many rational numbers are there between the 30 by 100 to the 70 by 100. Again, you may call it as a 31 by 100, 32 by 100, 33 by 100, up to what? 69 by 100. You will agree? You will agree with this point? Or again this one I can write 300 upon 1000. Okay, again it is same. Again the 3 by 10 I can write in this form, 300 by 1000. And here again 7 by 10 I can write 700 by the 1000. Again now you have to think. 30 means 301 by 1000, 302 by 1000. You can go up to like that. Means there are the infinite ways to write this one, right? See, if you replace the, again if I write the one more zero, 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 then what will happen? Is it possible to count in between the two rational numbers? How many rational numbers are there? No, right? So then what is the conclusion for this? There are infinite rational numbers present in between the two rational numbers. This is a conclusion. Okay? You got it? So, there are the infinite rational number present in between the two rational numbers. Okay. Or else I will explain with one more example if you want. See. Same question you can take with the one more rational numbers. How many rational numbers are there between minus 1 upon 10 to the 3 upon 10? 3 upon 10. Okay. Now, obviously, you will think, right, minus 1 to 10 means 3 by 10. You will write like this, no? How? 0 by 10 you will write, or you will write 1 by 10 and 2 by 10. You will write, okay, like this you will write, okay. You will think like this, no? There are the only 3 rational numbers present in between the 2 rational numbers. You will think like that, right? See, if I ask you how many rational numbers are there between minus 1 by 2 to the 3 by 10, you will think, okay, maybe there are the only 3 rational numbers in between the 2 rational numbers. Okay, you may think like that. No, right? So what if I wrote this minus 1 upon 10 is equal to, if I wrote minus this, then this 3 by 10, if I wrote then are you able to count in between these two to the how much? 3000 divided by how much it is? 1 lakh. Then there are the how many rational numbers in between them? You got the point? You understood what is the point I want to convey you? There are the infinite rational numbers in between the two rational numbers. See, I ask you how many rational numbers are there between minus 1 by 10 to the 3 by 10. Okay, you may have think, okay, maybe there are the only 3 rational numbers in between the 2 rational numbers. No, not at all. Not possible, because this 1 by 10 I can get in this form and 3 by 10 I can get in this form. Now how to count in between these? Minus 10,000 divided by 1 lakh and 3,000 divided by the 1 lakh. In between again how many rational numbers are there? Again this one I can write in any other form, right? I can add one more zero. Again here also add the one more zero. Again it is a n number of the rational numbers, right? So what is the point I want to convey means, there are the infinite rational numbers in between the two rational numbers. There are the infinite rational numbers in between the two rational numbers. Okay. Or else in a simple way, if you want, that also I will explain it. See, in a simple way, if you are not understanding this also, I will explain it one more way. See, take this number axis. This is a 0, this is 1 and this 2 minus 1. One more way to represent. Okay. Here and 1 and 2 are the two rational numbers. You will agree with this? All the integers are the rational numbers. So what I am telling, in between the two rational numbers, I am telling here there are the infinite rational numbers. Are they? I am telling, in between the two rational numbers, there are 1, 2 are the rational numbers. In between the two rational numbers, there are infinite rational numbers are present. How? Just you have to take the average of these two numbers. What? 3 by 2. 3 by 2 is what? See, 3 by 2 is lies between the 1.5, something like that. It will come somewhere here. Right? You can write this in a 3 by 2. Again, next, you have to take the average of this. 1 plus 3 by 2 divided by the 2. Then it is what? 5 by 2 into the 2. This is nothing but a 5 by 2 into the 1 by 2. This is nothing but 5 by 4. And the 5 by 4 is what? 1 point something 1.2. So you can write 5 by 4. 5 by 4 somewhere here. Again you can take the average of these two numbers and average of these two numbers. You can take the average of these two numbers, or you can take the average of these two numbers. The whatever the number will come, again you have to represent somewhere it will lie between the 1 to 2 only. Okay, see, if you take the average of 5 by 4 plus 2 ka average, then it is in what? 5 plus 8, 4 into the 1 by 2, right? It is 13 by 4 into 1 by 2 is nothing but a 13 upon 8, right? Again 13 upon 8 lies between the 1 and 2 only. 13 by 8 somewhere you count here. Then you can take 13 by 8 average you take, or 3 by 2 1 by this 13 by 8 average you take, or the 5 by 4 13 by 8 average. Like this cycle will continue. It never ends. So that is the reason what I am telling, in between the two rational numbers there are the infinite rational numbers. I hope you will get the point. Okay, we are getting this point. Okay, what is the conclusion? There are the infinite rational numbers in between the two rational numbers. Okay, now we will end this class, and one more class I will take. That is exercise 1.2 I will solve in the next class. After that we will go to the linear equation in the one variable. Within 2 to 3 on 4 o'clock I will start the class. Okay, now we will end the class. Thank you.